Take a look at question number 11. Question number 11 uh, gives us an inductance there, and it wants us to find the current and energy at this time, and then voltage and energy at this time. So we look at our graph, we have current, we also have time. So let's kind of go write what we know. So a little bit bigger than that. L is going to be equal to 2 henries. And so at time is equal to 0.1 seconds. We want current and energy. But to do this, we're going to need some equations. So from our equation sheet, we have for energy through an inductor at a certain time, it would be 1/2 Li squared. Okay. And looking at this here, if we're looking for the current, so I'll call this like part A. So for part A, they want the current and energy. This is already given to us right here in this graph, current. So at time 0.1 seconds, we can see that our current is just 3 amps. So I of 3 seconds is 3 amps. Okay. Easy enough. Then all we got to do is to find our energy. We'll just plug into this equation, Li squared, where 1/2, this will be 2 henries, I will be 3 amps, square that. We will end up with 9 joules. And it occurs to me, this is supposed to be 0.1 seconds. 0.1 seconds. Then part B is for time is equal to 0.1 seconds. Part B wants us to find the voltage and the energy at time is equal to 0.2 seconds. Okay? So we need another equation. So voltage through an inductor, time is going to be L di dt. Right. So how do we find that? What it means is that we'll multiply the inductor value by the change in current divided by the change in time. So the slope. So let's look at our graph. Let's see. We know L is going to equal 2 henries. But our di dt, we're looking from like here to there. That's our slope. Di dt. We'll have final minus initial. So final current is 0. Initial current is 3 amps. Our initial time, our final time is 0.2. And our initial time is 0.1 seconds. So we will get negative 3 over 0.1, which will give us negative 30. So voltage, the inductor, times 0.2 will be 2 henries and negative 30 amps per second. and then V of L 0.2 seconds will be negative 60 volts. Then finally, all we got to do is go back and look at the amount of energy that we have stored up. So at time 0.2 seconds, if we go and plug in our Li squared equation, get 1/2 2 henries. Now our I, if we look right here at 0.2 seconds, we see that value is 0 amps. So therefore, W of L at 0.2 seconds is equal to 0 joules. And that matches up with everything we have over here.